March 1944. The war in the air had entered a new phase. American bombers now crossed the skies over the Reich almost daily, their destinations deeper, their escorts bolder. But when German soldiers discovered a mostly intact American fighter in a muddy field west of Brandenburg, the officers who inspected it quickly realized this was no ordinary machine. The aircraft was a P-51 Mustang, its olive drab paint scorched, its propeller bent, its pilot already taken prisoner. Despite the damage, its fuselage remained largely intact, a rare prize for Luftwaffe intelligence. Within hours, the wreck was loaded onto trucks and transported north to Rechlin, Germany's secret testing facility. It was here that captured Allied aircraft were studied, flown, and dissected, their secrets laid bare for the Reich's brightest engineers. Inside the main hangar, the Mustang stood beneath harsh floodlights, surrounded by officers, scientists, and technicians. Clipboards in hand, they circled the plane like surgeons around a patient. They measured every surface, noted every bolt and rivet. The Allison-built Packard Merlin engine drew particular interest, its supercharger compact, its exhaust stacks clean and efficient. German analysts compared it to their own Daimler-Benz designs and murmured quietly among themselves. The Mustang was faster than most had expected, but that wasn't what shocked them. It was the flight log and maps found inside the cockpit. According to the mission data, this aircraft had escorted bombers all the way to Berlin and back to England. Impossible, they thought. A single-engine fighter could not fly that far, not with its known internal fuel capacity. Engineers began calculating. Internal tanks, about 269 gallons of fuel. Range, perhaps 1,200 kilometers at best. Enough to reach Berlin, but not enough to return. So how had this machine done it? What hidden secret allowed a Mustang to stretch its range across the heart of Germany and live to tell the tale? The answer would not come from its cockpit instruments, nor from its engine. It would come from something the soldiers had nearly overlooked. Two strange, discarded shapes found a few kilometers from the crash site. Light. Hollow, torn at the seams. Objects that looked almost like oversized canisters or fuel tanks, yet they were not metal. They were paper. The Luftwaffe had captured its first clue, and in those fragile, disposable tanks lay one of the simplest, yet most devastating innovations of the entire air war. At Rechlin, the investigation continued. Blueprints were drawn, equations scribbled across paper. The German engineers were confident at first, convinced that the Mustang's range could be explained away by fuel efficiency or favorable winds, but the numbers refused to agree. A P-51's internal fuel load, 2 wing tanks and 1 fuselage tank, totaled 269 U.S. gallons. At cruise power, that meant roughly 750 miles of range, enough to reach Berlin from England only under perfect conditions and with almost nothing left to return. Yet reports from Luftwaffe units showed something impossible. Mustangs were not only reaching Berlin, they were loitering above the city, engaging German fighters, and still returning home. That meant one thing. Somewhere, the Americans had found a way to carry more fuel. For days, the analysts studied the captured aircraft. No secret compartments, no additional tanks hidden in the wings. Every inch of the Mustang had already been mapped. Then one of the field officers returned from Brandenburg with a curious report. 2 light, crumpled canisters had been recovered from a nearby field, about the size of aircraft drop tanks, but unlike any the Germans had seen. The officer described them as flimsy, almost fragile, so soft that one could dent them with a finger. And yet, the smell of aviation fuel was unmistakable. The engineers called for them immediately. When the strange objects arrived, the entire hall gathered around. Each measured just over a meter in diameter, streamlined with aluminum fittings, but the body itself was not metal. It was brownish, fibrous, and light as air. A technician struck it gently with a wrench. Instead of a metallic ring, it gave a dull, hollow thud. At first, they thought it was some kind of wood composite, but when they peeled back a torn edge, they discovered something extraordinary. Layers upon layers of laminated craft paper, bonded with resin and coated with fuel-resistant lacquer. They weren't built to last. They were built to be used once, then thrown away. Tests showed each tank could hold 108 gallons of high-octane fuel. 2 tanks would give an additional 216 gallons, nearly doubling the Mustang's total range, from 750 miles to more than 1,500. For the first time, the math worked. The mystery of the Berlin to England round trip was solved. But what truly stunned the Germans wasn't the range. It was the material. Paper. No metal, no aluminum. No strategic resource required, just paper, pressed, lacquered, and shaped by the millions. In that moment, the Luftwaffe scientists realized what they were up against. While Germany's aircraft industry was crippled by shortages and bombings, the United States had found a way to build a war machine that required almost nothing rare. A weapon of industry, not complexity. And this was just the beginning. At Rechlin, the mysterious fuel tanks were placed on a long wooden table beneath bright lamps. Around them, German chemists and materials specialists gathered, men who had spent years studying alloys, plastics, and fuels for the Luftwaffe's most advanced aircraft. But never paper. They cut small squares from the tank's surface, weighing, measuring, burning. Each test revealed another layer of ingenuity, a simplicity so effective it bordered on genius. The structure was made of laminated craft paper, bonded with phenolic resin, then sealed in alcohol-based lacquer to resist gasoline. The outer skin gleamed faintly, smooth to the touch, almost like waxed leather. When exposed to flame, the material didn't melt. It charred slowly, refusing to burst. It weighed less than half of aluminum and cost almost nothing to produce. The chemists exchanged uneasy glances. This wasn't an accident. It was design, deliberate, efficient, and brilliantly pragmatic. Each tank could be manufactured in ordinary paper mills instead of aircraft factories, avoiding the bottlenecks that crippled German production. No rivets, no welding, no strategic metals, just paper, glue, and lacquer. The scientists realized that this single innovation explained more than just the Mustang's range. It revealed a philosophy of war unlike anything they had imagined. While German engineers chased perfection, high-performance, precision-built machines, the Americans were pursuing something else entirely: mass production, adaptability, and scale. To the Reich, materials like aluminum were precious, rationed, and guarded. To the Americans, they were optional. If metal was scarce, they would use wood. If wood was too slow, they would use paper. At Rechlin, one of the technicians reportedly murmured, "They can build these faster than we can shoot them down." He wasn't wrong. Within weeks, reports from the front confirmed that hundreds of such tanks were being dropped daily across Europe, littering fields and forests with fragments of soaked paper and twisted fittings.
To German civilians, these strange husks became symbols of something terrifying: the enemy's limitless capacity to build, waste, and replace. In war, innovation often begins with brilliance, but victory belongs to the one who can manufacture it. The Luftwaffe's scientists now understood that the P-51's greatest weapon wasn't its guns, its speed, or even its engine. It was the industrial machine behind it, and that machine was unstoppable. The discovery of the paper tanks sent shockwaves through the Luftwaffe's command. They were forced to confront a chilling reality. If America could turn paper into fuel tanks, then perhaps nothing was beyond its reach.
By late March 1944, the report from Rechlin reached the Luftwaffe High Command. It was brief, but devastating. The Americans had developed disposable fuel tanks made of paper, a material so simple, so cheap, and so fast to produce that it rendered every German attempt at strategic conservation meaningless. For years, the Reich had poured resources into perfecting efficiency, optimizing every liter of fuel, every kilogram of aluminum, every precision-machined part. But now it faced an enemy that had solved the problem by changing the rules entirely. Across the Atlantic, the United States had become a war factory unlike any in history. Every day, assembly lines roared from Detroit to Los Angeles. Ford, General Motors, and Packard produced engines and airframes on a scale that defied comprehension. The same industrial spirit that built automobiles now built Mustangs. The same mills that once rolled paper for magazines now pressed fuel tanks for fighters. In the span of a single week, American factories could produce more aircraft drop tanks than Germany could manufacture entire fighter planes. To the Luftwaffe's engineers, it was more than a technological difference. It was a cultural one. German engineering prided itself on precision. Every aircraft was handcrafted, measured, perfected. Each Bf-109 or FW-190 represented thousands of man-hours, a masterpiece of metallurgy and design. But mass production was never the German way. Quality came first. Quantity was an afterthought. Now that philosophy had become a fatal flaw. In the United States, perfection was defined differently. Not by the elegance of a single machine, but by the ability to produce 10,000 more just like it. A paper fuel tank wasn't meant to impress engineers. It was meant to win wars. At Rechlin, one senior officer wrote in his notes, "We are fighting an enemy who wages war with his factories, not his soldiers." It was a quiet admission, and an accurate one. Each paper tank symbolized something far greater than fuel capacity. It represented the industrial strategy that underpinned Allied victory, a weapon that required no genius to build, only organization, abundance, and time. And time was something Germany no longer had. As the Mustang's range extended, no German city remained safe. Bomber formations, once vulnerable beyond the Rhine, now flew deep into Saxony, Thuringia, and Brandenburg, always under the watchful guard of P-51s that refused to turn back. The Luftwaffe's last advantage, the range barrier, had collapsed. The paper tank had changed the geometry of war, and with it, the skies over Germany would soon belong to the enemy. Spring 1944. The skies above Europe changed. The arrival of paper drop tanks had transformed the P-51 Mustang from a regional escort into a continent-crossing predator. For the first time in the war, American fighters could accompany bombers all the way to Berlin and back. And when they arrived, the Luftwaffe was waiting, but so were the Mustangs. Over the heart of Germany, dogfights raged where none had existed months before.
High above the clouds, silver Mustangs dove from the sun, their Merlin engines howling. FW-190s and BF-109s, once masters of their home skies, now found themselves outnumbered, outranged, and outlasted. Every time a German formation rose to intercept the bombers, it faced swarms of escorting P-51s, fresh, fueled, and relentless. And when the fighting ended, the Americans simply turned west and flew home. The range advantage was gone. The Luftwaffe strategy, built on the assumption that Allied fighters couldn't reach central Germany, collapsed overnight. From March through July 1944, Luftwaffe fighter losses skyrocketed. Entire Gruppen were wiped out in single engagements. The pilots who survived returned shaken, describing an enemy that never seemed to run out of aircraft or fuel. The German defense network, once the shield of the Reich, was bleeding to death. Training schools could not replace losses fast enough. By summer, the Luftwaffe had lost over 40% of its experienced fighter pilots. And the bombers kept coming. Berlin, Leipzig, Munich, Schweinfurt, city after city, factory after factory burned under relentless attack. For the men in the Air Defense Command, the reason was painfully clear. Those flimsy-looking paper tanks, once mocked as curiosities, had made the difference between defending the homeland and watching it burn. The irony was bitter. A device so simple, so fragile, had undone a war machine built on complexity and precision. German civilians soon began finding the remnants of those tanks scattered across fields and rooftops. Crumpled shells of fuel-stained paper with American markings still visible through the soot. Children played with them. Farmers used them as buckets. But for the soldiers who recognized them, they were something else entirely. Symbols of defeat. Each discarded tank was a reminder of what Germany could not match. The industrial abundance of an enemy that built by the millions and threw away what others rationed. By the autumn of 1944, Luftwaffe commanders privately admitted what few dared to say aloud. The war in the air was lost. And it wasn't lost in the skies. It was lost in the factories.
The paper tank was not just a tool of range. It was a message. A statement from a nation that could afford to turn its own waste into weapons and still outproduce every rival on Earth. The Luftwaffe never recovered, and from that moment on, the skies above Germany belonged to the Mustang. By the spring of 1944, the Luftwaffe had not only suffered tactical defeat, but psychological collapse. The discovery of the paper fuel tanks at Rechlin was more than a technical revelation. It was a psychological earthquake that rippled through every level of the German war machine. At first, disbelief, then anger, and finally, resignation. To German engineers, the idea was insulting. A vital flight component made of paper? It went against everything they stood for: precision, craftsmanship, permanence. In the German mindset, technology was art. A machine was a reflection of discipline and genius. Every bolt, every rivet mattered. But the Americans, it seemed, no longer cared about art. They cared about results. And that was the most demoralizing truth of all. At Luftwaffe headquarters, officers quietly admitted that the Reich could never match this level of industrial creativity. It wasn't just about resources. It was about mentality. The Americans built war as though it were an equation to be solved. Efficiency over elegance, speed over sophistication, quantity over pride. To the German psyche, trained to believe in superiority through craftsmanship, it was an alien kind of warfare, and yet it was winning. Reports from frontline units soon confirmed the psychological toll. Pilots returning from combat spoke with a tone of disbelief. "They're everywhere," one fighter ace wrote. It doesn't matter how many we shoot down, more come the next day. The Allied air forces were now viewed not as opponents, but as an industrial storm, a machine that never tired, never stopped, and never ran out of fuel. The paper tanks symbolized that relentlessness. They were the physical proof that the enemy could turn weakness into strength, limitation into advantage. Within German propaganda circles, the story of the captured Mustang was quietly suppressed. It was too dangerous, too revealing. Publicly, the Luftwaffe sting boasted of new secret weapons, the Me-262 jet, the V-1 flying bomb, the V-2 rocket, symbols meant to restore faith in German ingenuity. But privately, officers at Rechlin knew the truth. While the Reich invested months in perfecting single prototypes, America had mastered the art of producing imperfection by the millions and making it work flawlessly. In one Rechlin memo, a frustrated engineer wrote, "They win not because they build better machines, but because they build machines better." A subtle distinction, and the one that would define the outcome of the war. From that point onward, the Luftwaffe's fight became a formality. Its aces fought bravely, its engineers worked tirelessly, but the war had already shifted beyond courage or skill. It was now a contest of systems, of who could adapt faster, think simpler, and produce longer. And in that contest, the paper fuel tank was not just a tool, it was a mirror, showing Germany the reality it refused to see. In the months that followed, the Luftwaffe's morale never truly recovered. The sound of the Mustang's Merlin engine became, to many German soldiers, the sound of inevitability, the sound of an empire in retreat. By April 1944, Rechlin was no longer just a testing facility. It had become a refuge for Germany's last hope, a fortress of scientists, engineers, and pilots racing against time itself. Amid the smoking ruins of the Reich, the captured P-51 Mustang stood as both marvel and menace. To the men at Rechlin, it was a window into the enemy's mind, a machine they were determined to understand, dissect, and if possible, surpass. Inside the hangar, the Mustang's skin had been carefully removed, revealing the heart of the machine, the Packard-built Merlin engine, a near-perfect copy of Britain's Rolls-Royce design. Engineers marveled at its simplicity. The lines were clean, the maintenance points intuitive. Every system seemed built for mass production and rapid repair, a stark contrast to the over-engineered complexity of German aircraft. "They built this for soldiers, not engineers," one Rechlin technician remarked. That observation said everything. Rechlin's pilots were ordered to fly the P-51 daily, testing its limits against the Luftwaffe's best interceptors, the FW-19A-8, the Bf-109G6, and the experimental Me-410. The results were unsettling. In climb rate, the Mustang matched or exceeded the German fighters. In dive speed, it was superior. And with its long-range drop tanks, it could stay aloft for hours, long after the German aircraft had returned to base. Even its cockpit layout impressed the test pilots. Clear, simple, ergonomic, everything the Luftwaffe's crowded panels were not. In one test report, a veteran pilot wrote, "It is not invincible, but it is perfect for its purpose. It fights longer than we can. That is its advantage. Time." That line was underlined twice in red pencil by the Rechlin commander. Yet even as tests continued, Rechlin itself was changing. The war was closing in. Allied bombers had already struck nearby airfields. Fuel was scarce, replacement parts impossible to find. Still, the engineers kept working. They documented every control response, every fuel pressure reading, every cooling characteristic of the Merlin engine under high load. For a brief moment, they were no longer soldiers of a collapsing Reich. They were scientists, desperate to preserve knowledge, to understand why they had been defeated in the sky. By June, the P-51 at Rechlin had flown over 24 test missions, but time had run out. Allied reconnaissance had identified the facility. In late summer 1944, heavy bombers from the 8th Air Force struck the region in a devastating raid. The Rechlin airfield burned for hours. Many of the archives, years of data, prototype designs, flight recordings were destroyed. The Mustang was damaged beyond repair. When the smoke cleared, the engineers found its remains in a crater, its wings sheared away, the paper fuel tank still faintly visible amid the ash. It was a haunting sight, the very symbol of Allied ingenuity, destroyed by the same industrial storm it had represented. Rechlin's work continued for a few more months, but the spirit was gone. The captured Mustang's lessons were learned, and its message understood too late. A final report, written in pencil and dated July 1944, ended with a single line. The enemy fights with time and material. We fight with courage and hope. Only one of these can be manufactured. That was Rechlin's epitaph, and the last legacy of the captured P-51. By early 1945, the war had turned decisively against Germany. The Luftwaffe, once dominant over Europe, was a shadow of its former self. Fuel shortages grounded squadrons. Experienced pilots were dead or captured, and the once proud testing grounds of Rechlin now stood vulnerable to Allied advance. Rechlin's scientists and engineers had tried to salvage what they could. Prototype aircraft, flight records, and analyses of captured Allied machines were hastily packed and hidden. The P-51 Mustang that had so haunted German intelligence was long gone, destroyed in raids. Yet its lessons lingered, etched into reports and the memories of every man who had seen it fly. We knew we were behind, but seeing it, flying unopposed, changed our understanding. Victory had already shifted beyond the battlefield. It was industrial. Allied forces finally reached Rechlin in April 1945. The airfield was in ruins. Burned-out hangars, cratered runways, and scattered remnants of aircraft littered the landscape. Among the wreckage, they discovered the fragments of Germany's intelligence files, flight test reports, material analyses, and detailed drawings of the captured Mustang. It was a historian's treasure trove. Every measurement, every calculation, every insight into Allied aviation technology meticulously documented. The Allies learned what the Luftwaffe had discovered in 1944. The P-51 Mustang, with its long-range capabilities, had rendered the German heartland vulnerable. Paper drop tanks allowed American fighters to escort bombers to any target, then safely return. German aircraft were technically impressive, but could not match the Americans in production scale. The captured reports confirmed what the battlefield had already revealed. Germany could not compete with the industrial might and efficiency of the United States. Rechlin's fall marked more than the loss of a single airfield. It symbolized the collapse of German technical supremacy and the harsh reality that war is won not only in the sky, but in factories, workshops, and assembly lines. The engineers who remained at Rechlin were captured or fled, many later contributing their knowledge to post-war aviation programs in both the United States and the Soviet Union.
Their analyses of the P-51 and its drop tanks informed designs for decades to come.
The Mustang itself became legend. Its design, its endurance, and the ingenuity of its paper fuel tanks continued to serve as a symbol of how industrial capacity could decide wars. Even in ruin, Rechlin's story served as a lesson. Technological superiority alone is never enough. Without the means to produce, supply, and sustain, even the finest machines cannot change the tide of war. By April 1945, Rechlin was silent. The war would end in weeks, but the echoes of the captured Mustang and the stark truth of Allied industrial power would reverberate long after the last German fighter had fallen. The captured P-51 Mustang at Rechlin was more than a fighter aircraft. It was a lesson in industrial warfare, a tangible reminder that the outcome of modern conflict depends as much on factories as on pilots. The engineers and pilots who analyzed it in March 1944 discovered something profound. The Mustang's range, performance, and reliability were remarkable, but the real power lay in how it was produced. The paper drop tanks symbolized the Allied advantage. Lightweight, inexpensive, and manufactured from non-strategic materials, they solved the fuel problem without consuming precious aluminum. Each tank was expendable, mass-producible, and perfectly adequate for its purpose. To the Germans, this was almost inconceivable. The Americans had resources to spare, labor to spare, and the organizational capacity to turn a simple idea into a war-winning tool. Rechlin's reports documented it all. Industrial scale mattered more than perfection. German engineers built technically superior aircraft, but each required skilled labor, specialized tools, and months of assembly. Standardization and interchangeable parts allowed American factories to produce hundreds of aircraft monthly. Efficient design for mass production meant even semi-skilled workers could contribute effectively. The Mustang, the drop tanks, and the supporting industrial system created a force multiplier that Germany could not counter.
From Rechlin, German engineers realized that technical brilliance alone could not win a war. The Allies did not need a perfect fighter. They needed enough fighters. Quantity, logistics, and operational sustainability outweighed single aircraft performance. The lessons went further. Resource optimization, using paper instead of metal, showed how scarcity could be turned into advantage. Expendable technology, tanks designed for single use, reduced logistical complexity. Mass production philosophy, designing for assembly lines, semi-skilled labor, and interchangeability, reshaped the understanding of modern war. For the Luftwaffe, these were bitter truths. No amount of training, skill, or tactical innovation could overcome the overwhelming tide of Allied aircraft. The Mustang was not just a weapon, it was a symbol of industrial inevitability. By mid-1944, German planners understood that every paper drop tank falling over Germany was a visible sign of their disadvantage. It was a reminder that the Allies could project power anywhere in the Reich with impunity. The strategic lesson endured long after the war. Victory in modern conflict is determined not only by courage in the sky, but by the ability to produce, supply, and sustain. The P-51 Mustang and its drop tanks were a perfect case study in how practical solutions and industrial scale combine to create decisive advantage. Rechlin's files, the technical drawings, and the analyses preserved by the Allies became part of post-war aviation knowledge, influencing aircraft design, production methods, and military strategy for decades. In the end, the Mustang taught a simple truth. It was not the individual aircraft, nor the pilot alone that won the air war. It was industry, efficiency, and the courage to innovate at scale.
And in that lesson
captured on a cold March day in 1944, lay the blueprint for Allied air supremacy and the inevitability of the Reich's defeat.
The war ended in May 1945. Germany lay in ruins, its Luftwaffe decimated, its cities battered, and its factories destroyed. The lessons learned at Rechlin from the captured P-51 Mustang and its ingenious paper drop tanks endured far beyond the battlefield. The Mustang itself continued to serve around the world. Korea, where its endurance and reliability made it an exceptional ground attack aircraft. Post-war air forces, where its range, speed, and versatility cemented its reputation. Over 100 P-51s remain airworthy today, preserved by collectors and museums flying as reminders of history. The paper drop tanks, though simple in design, became legendary. Few survived, but those that did are now museum artifacts, illustrating a wartime lesson in industrial ingenuity. Adequate solutions can outperform technically superior designs if scaled effectively. Non-strategic materials and mass production can achieve strategic impact. Industrial capacity, applied intelligently, decides wars. Rechlin's engineers, many of whom survived the war, carried their knowledge to the United States, the Soviet Union, and Britain. Their insights into American mass production, standardized components, and efficient design influenced post-war aircraft development. Modern systems engineering, the principle of designing for manufacturability, owes part of its foundation to what German engineers observed in March 1944. The story of the paper drop tank also became a teaching tool. Military academies and engineering schools study it as an example of industrial problem solving, where practicality outweighs technical perfection. Every layer of laminated craft paper, every brass fitting, and every carefully calculated fuel capacity was designed for purpose, not prestige. In Europe, the Mustang and its drop tank symbolized the industrial superiority of the Allies, the logistical mastery that allowed sustained daylight bombing and complete air dominance. The Luftwaffe, constrained by resources, fuel shortages, and pilot losses, could only react, never dictate, the tempo of the air war. The broader lesson is timeless. In modern conflicts, production, supply, and efficiency can outweigh tactical brilliance. A well-designed system, produced at scale, can shape the outcome of war even against technically sophisticated opponents. The captured P-51 Mustang at Rechlin was more than a machine. It was a messenger, a symbol, and a warning that overwhelming industrial capacity can determine victory. That innovation, even in the simplest form, becomes decisive when applied at scale, and that in the modern era, war is fought as much in factories as in the sky. The paper drop tanks that once fell harmlessly over Germany are now relics, but their story continues to teach generations about strategy, industry, and the true nature of air power. The P-51 Mustang and its ingenious drop tanks did not just escort bombers, they escorted the Allies to victory. And in doing so, they left a lesson as enduring as the war itself, that production, ingenuity, and efficiency can be as lethal as the sharpest blade in the sky. German scientists examined a Mustang's drop tanks, then realized how it reached Berlin and back.